Brilliant, thank you. Well, good morning, everybody. Welcome to day 2 of Trailhead DX. How's everybody feeling? Are we awake yet? After the session, make sure you go grab coffee and snacks. That'll help you wake up a little bit, I promise. You are hopefully all in the right place, here to learn about Apex testing. Yes? Okay, cool. I don't normally get that for testing, so thank you. All right. We are a ready-to-go crew. Did everyone enjoy the party last night? Okay, cool. All right, we've covered all of the typical questions I have to ask, I promise. All right, my name is Heather Dykstra. I'm a developer evangelist at Salesforce. I've been at Salesforce for about 8.5, 9 months now. And I love talking about 2 things. 1, artificial intelligence, and 2, testing. So if you have any questions related to either of those things, I'd love to chat. You can follow me on Twitter at @SlytherinChica. Yeah, it's a little embarrassing, but I'm a Slytherin. So hopefully you can remember it. Before I get to the really cool stuff, I do have some forward-looking statements that I will be making today. So make sure you make any and all purchasing decisions, be that product or stock, based on what's currently available on Salesforce.com, and not any of the stuff you'll hear from me today or later in the different keynotes that'll be happening throughout the day. So we've got a bit of a road ahead. This is a 40-minute session. I've got about 35-ish minutes of content, and then I'll have 5 minutes for questions, which I know are going to be a little intense. So if I don't answer it or you don't feel like I answer it fully, I will be available after the session to keep talking. So we're going to talk about 3 main things. I don't feel like a session about testing is right without a little bit of why we should be doing it. So I'm hopefully going to inspire you to keep doing what you're already doing and writing amazing tests. Then we're going to cover testing best practices. This is where we're going to spend the majority of our time together. I'm going to show you a bunch of different pieces of sample code and show you why it's good and maybe how it could be better. And then I'll cover some tools for success. And that's where I'll make my forward-looking statements, where we'll talk about some of the announcements we made yesterday and that you'll get to continue to see throughout the day today. So let's soapbox for a moment and talk about why we should test. Because it's really easy for all of us to think, well, we should test because our manager says we should. Or we should write tests because Salesforce requires that I have 75% code coverage before I can deploy. But none of that is inspiring. None of that makes me want to write my test code. That makes me have to write my test code. But I really believe that testing makes us better developers. So I love writing test code. So the 3 main things that it does to make us better is that the first thing is that it reduces the cost of change later. You probably already know this, but if you've got a full test suite and you go and you refactor how a method works, you want to make sure that that test is still passing. So if you write good test code, you don't have to worry about it. You just know that your functionality still works. But if you're not writing good test code, then you have to go and write more test code, and you're adding onto your technical debt. So writing good tests from the beginning reduces the cost of change in the long run. It also helps you identify bugs. Now, I have a little bit of a story to tell here. I have a good friend of mine who works in finance, and she's writing an application for her team that literally is saving them hundreds of hours a month. They're automating all of these processes with literally a button click. And so she goes through, she writes the whole application. She's written her minimum amount of test code, so she's feeling good. She gets it to QA. She actually has a really good suite of QA testers. They're testing everything just like they should. And everything's passing. Sweet, we're good to go. And then she deploys to production. And it breaks. The whole thing. In fact, it's so broken that her users can't even log into the system. And she's like, what happened? And it turns out it was a bug she'd seen previously in a different application that she'd written. And if she had just remembered to test for it, she would have caught that she had hard-coded an ID to the sandbox and not to production. Oh, and she hard-coded an ID. Not good. But if she would have written her test like she knew she should, she would have caught that bug. The last thing is that it helps Salesforce help you. We have 3 amazing innovative releases per year. And with each of those releases, we actually run every single customer and partner test in our own orgs before we even push it out to your sandboxes. That means that all of your code is running and being checked and helping us catch our bugs before you even have to see them. That means less work for you in the long run, which is pretty great. So we talked about why, but another thing that's argued about a lot is when. When do I write my tests? Do I write them as a test-driven developer and write them very first? Or do I write all of my code features and write them at the end? Or am I one of those weird developers that writes a function and then writes a test, and then writes a function and then writes a test? But in the end of the day, they're all correct. Everybody's right, because you're all writing tests. And that's the important thing. Knowing that you have written a test for your feature. Now, it's not right if you deploy your code and then 6 months later, you write the test. That's not okay. It should be within a time box span. If you do sprints, you should be writing those tests within your sprint. But if it's before, during, or after, is really up to you and your company. So don't let that stop you from feeling like tests are something that is impossible to get through. And then I have one final point here on some of the softer skills. Code reviews. Code reviews are essential for test code because code is code is code is code. And most often when I see other orgs or I interact with other orgs, what I realize is that, yes, there's test code, and yes, we're at 75%, but nobody looked at the test code to make sure it was doing anything. And that's not good. So make sure that you're actually reviewing your test code, because test code doesn't get test code about it. So who else is going to do it? Okay, I'll hop off my soapbox, and we can get back to some best practices. Okay, so my first tip for best practices. You should write your code for testing. So regardless of when you write that test code, your code should follow these pretty simple tips. If they're not already part of your guidelines for your code system, I would encourage you to make them part of it. The first thing is that all your methods should be tightly focused. This is a common object-oriented practice, but it is forgotten about in Apex. That's sad. So let's write those small, tightly focused methods. But I know what you're thinking. I have really complicated functionality, Heather. That's not going to work for me. But it is, because you can compose that advanced functionality of all those small. That's what they're for. So how do I do this? Well, I've got some tips and tricks here. 1, keep your methods to no more than 20 lines long. That's just a good practice. 2, make sure that your method arguments are no more than 4 per method. I see this all the time where you're working with 6 different objects, so you think, okay, well, I need to have an account and an opportunity and a contact and my special child object. Oh, and I have an object that ties all those together, so those should all be part of my method. But that's not how we should be using method parameters. The next thing is that you should be writing your visual force controllers to a single wrapper object. That's pretty much best practice and in all of our sample code. And my favorite thing is using descriptive method names so that I don't have to write comments. If you look at my code, I'm notorious for having really, really long names. It probably doesn't help that I learned to code in Java, where we're really wordy. But it does actually help when you're writing test code to know what it is that you're testing. So my next tip is to use setup test data. And to do this setup test data yourself. You should never use see all data is true. And if you're using an old API, I don't exactly remember which version, I think it's 30 or before, you should have see all test data equals false on every one of your tests. Because otherwise, you're touching production data, and that's nasty. You don't want to do that. So you should also build your own test data. And I've got 2 different ways that I've seen actually work in practice. So the first one is this test factory by Daniel Host, whose name I hopefully pronounced correctly. I've got a bit.ly here to his GitHub repository where he posted his code. But basically, it's a factory that you don't have to write. You can just take it from online, and it will automatically help you create your objects for you. In fact, if you're doing bulk testing, you can actually have it create 200 things automatically for you that are all unique or more. So this is a really powerful way to massively create test data if you're not so worried about how that data is linked. I'm going to give everyone just another moment to take a photo of that. These slides will all be posted as well as the recording, so if you missed this now, that's okay. So my second tip is that you should be using test.load data. Now, the reason that you should use this is actually to empower your admins. So if you're writing a bunch of objects that are all intertwined, like I've got a contact and it links to an opportunity and it's also got accounts, that can get really tedious to make sure that you're getting all of the different connections correct. But if you use test data and you have everything in a static resource, your admin can go in and add those different things that you need. Like they have this edge case that they just caught where an account isn't tied to the contact, but it is tied to the opportunity. They can put in that data so that you can test against it. And then the developer doesn't have to do anything. You just watch the tests fail and know why. So test load data is really useful. The next thing around data is bulk testing. I cannot tell you how many times I've interacted with code that only tests one example, and that's just no fun. That means that it's not prepared for when it actually hits real time and your company goes from being 2 people to 30,000. So bulk test, even if you're only 1 person. So this is what my colleague says is his #1 most important tip. Use asserts. If you don't have an assert in your code, you're not actually testing anything at all. So luckily, Salesforce has 3 awesome assert methods. They're pretty simple. The first one just takes a Boolean, true or false, and an optional message. And then the other 2 are to check if something is equal to or not equal to whatever you're testing. They also all have that friendly message component so that you can have, again, good self-documenting code to tell you why something is failing. But these are not all-encompassing, and everybody's got a different experience, and this is not going to test everything you need. So you can write your own. You can pretty easily just extend an exception class and create your own. So again, going back to that account and opportunity comparison, maybe you're comparing a bunch of different things on opportunities, and you don't want to have 50 system.asserts. Well, when you write your own, you can just compare them all in an abstracted test class, and then actually just call your custom assert to make sure that you're doing it right. Now, the lovely thing about the fact that I've written this with an is test is that I've made this a utility class that I don't have to write code coverage for. So this doesn't impact your limits. It makes your code more readable, and it makes it easier for you to test really complex assert cases. Overall, asserts and exceptions are the only way to test Apex code. So you probably already know this. Start test and stop test are important parts of an Apex test. But what you might not know is why they're important. Maybe you see them in some test code and you're like, oh, that's great. We know when the test starts, we know when it stops, there's some stuff that happens before, cool. But in reality, these commands actually do something really awesome on the back end. Start test resets all your DML, CPU, and governor limits. That means that if you spent a lot of time writing out all of your test data, importing it, you're starting to hit limits, right, because you're bulk testing. that all goes away as soon as you say start test. You're good to go. Now what you're actually testing is your code and not all that other stuff you did before you got to the test that you are actually starting to run. Stop test is also super great because it forces asynchronous code to run. So if you're writing really complicated asynchronous methods and you want to make sure that they're being tested correctly, the only way to do that is to use stop test, because that will force your whole method to complete and any exceptions to be thrown if they need to be thrown. And then you can move forward and really properly use your asserts to test. So there's a typical pattern to this. We create our test data. We start our test. Then we use the test data within our test method. Then we stop our test. And then we write our assert. So all of those things that we talked about, those all go in this order. And then you have a test, which is pretty great. Here's a quick example of that, where I've highlighted the test start and the test stop. It's a pretty simple example, and we're going to continue to use our calculator class through the rest of the presentation. Our calculator class has a couple of functions. We've got an add, we've got a divide, we've got a multiply. Oh, and we also have play games, because this is one of those really cool calculators that you can play games on. So just keep that in mind as we continue to look at our different examples, because that's going to come back and be important. This is a pretty basic test, and I'm not going to dive into it right now, because we're going to show it again in a moment. So we know how to write a test. That's great. But we're here for advanced stuff. So let's talk about that advanced stuff. Positive and negative tests are two really important parts of testing. Positive tests are what you think of when you think of a normal test. They test the expected behavior. They don't just test one expected behavior, though. They test all of the expected paths that you expect a piece of code to go down. So that's pretty normal. Really, really easy example of a positive test, adding 1 and 17 in our calculator. 1 plus 17, that equals 18. Done. Positive test. I could write these all day, right? These are easy. Not so easy. Negative tests. They're only not so easy because they're slightly less intuitive. You have to wrap your mind around why they work. And the whole point of them is to prove that you're actually catching the errors and exceptions that you're expecting. So let's look at an example of that. Here's my negative test. This is that same test from before with start test and stop test. We're dividing by 0. Whoa, why would you test dividing by 0? Because that shouldn't work, right? That should throw an exception. So here we're saying we're going to try something. We're going to try to divide by 0. And then we're going to try to catch our exception. Now, this is a really common pattern when you're writing negative tests, to do a try-catch, because that catch will catch your exceptions for you, and then you can actually assert against that exception. Okay, so those positive tests are pretty easy. Negative tests, we feel like we can handle, so we should put them all in one long method, right? No, we shouldn't. They should all be in their own individual methods. So it's totally okay to have 100 tests for just one method. If that method is really complicated, maybe you've got different kinds of users who use it, or maybe it's just a particularly challenging method with a lot of edge cases. What's important is that you do test all those edge cases, but you don't test them all at once. So avoid those long test files. And I kind of just mentioned this, but we should be testing for profiles and permissions in every single piece of code that we write. I never see this, ever. So please start doing it today. And I'm even going to show you how. But the idea is that if you write a user-based test, then you're going to be actually proving out your security model. So if you've got an opportunity that only your execs should see, I want to see a test for it. I want to make sure that that's working. Now, I know you're thinking, but my admins are always changing. Everything's always different. My profile changes once a week. Well, maybe you should be speaking with your admin about those things. But you should definitely still be considering that when you're writing your test code. So here's an example of how to do a test with a profile. In this case, we're back to our calculator class, and we're running a quick test on playing a game. Now, what I've decided as the admin in my org is that teachers can play games on their calculators because they need a break sometimes. So I'm saying, all right, I'm going to create a user. We're just going to call them U because we're just going to use them in a test. And we're going to use our test library that I've written to get a user with a profile. So this is just a utility class that we've written. We're going to give it that teacher profile. Then we're going to store our result and run our method as that user that we just defined. We're going to start our test, stop our test, and then we're going to see, hopefully, that our teacher can play games as we expect. So this is a pretty solid, positive test. Now, on the flip side, here's a negative test. This negative test happens to not use try-catch, but it could. Again, we're doing the same thing we were doing before. We're assigning a user. This time we're just assigning them with the student profile. And students are in class, so they shouldn't be playing games on their calculator. So when we throw our play game, this time instead of using an assert equal, I'm just simply changing that to assert not equal and saying that the student shouldn't be able to play a game. So these are just with profiles, but profiles are not the only way we manage permissions in an org. We also manage them with permissions. So here's how we could set a profile and a permission set really easy, literally just one more line. So this time, I'm creating my user. They're just a standard user, everyday average person. But everyday average people that aren't necessarily students or teachers should be able to play games on their calculator. So let's give them a permission set that says, hey, they can play a game. All we're doing there is just saying assign user to a permission set. Pretty simple. And that's a standard utility class. Cool. We're good to go. So we're going to transition now away from the users and talk a little bit about mocking. How many of you have ever had to try to mock a service in a test? How many of you have struggled with mocking that service in a test? I know I have. It's pretty complicated. But the idea here is that if you're calling a web service, with testing, you can't actually call that web service. It's a little bit unintuitive, just like you can't actually send an email with a test either. So we use mocking to try and insert objects and do things with those objects like a web service would. But the access to that web service is not necessarily critical. So if you are trying to test the web service itself, you're going to have to do that a different way. But if you're just trying to test that what the web service sends back to you is working, mocking is your best friend. So let's look at some code. So I work with a lot of the people who used to be on Salesforce University and are now part of Trailhead. And I stole this slide from them. But basically, this is our example of how to write a mock test. You implement our interface HTTP callout mock. You create a global response request. And then you set the response values. This part's actually pretty intuitive. Say you want to make sure that there's a header on the web page or web service, there's some body, there's some other content. It's pretty easy to set that with just response.body or response.header. And then you can return that. But then we've written this utility class. Oh, and it is a utility class, so it's got that is test. We're not hitting any more code limits by writing this function. And then we simply call it in our test code by saying set mock and calling the function that we just wrote. Now, like I said, this is a really, really basic example. And so if you have more questions on this, I'd love to chat with you afterwards to kind of understand what problems you're seeing, because I can't address them all in the next 10 minutes. Okay, so those are the main tips and tricks to writing good test code. Let's talk about how you can actually do this in practice at your company with some extra tools for success, because Salesforce is working on that. My first tip is that when you're writing these advanced tests, you should be using continuous integration. This allows you to test all of your code before you deploy it to production. It's super powerful. With tools like Travis CI or Jenkins, you can do this in an instant, and you can fully customize it to whatever your business needs. With Salesforce DX, we're working on making these features even more prominent in our tooling to work for you. This allows you to have multi-developer support. If you're working with a bunch of different people at your company, you're not knowing what they're writing in their test code, and that's not helpful. So when you use continuous integration, you can schedule builds so that you can know whether or not you're the person who broke the test or they're the person that broke the test, which is something that I struggled with daily. And then finally, you can know if you're at code coverage or not. When we're writing tests and we're just running them in our sandbox, those numbers are different than the numbers we get in production. It's a little wonky. So if we use something like continuous integration, we're able to more easily test to make sure that we are getting up to that 100% code coverage goal that I promised in this session title. The next tool that I'd like to point out is Apex Tail. This is brand spanking new that we just announced yesterday in the DX tooling suite. Now, these commands may have changed because I wrote this slide 2 weeks ago. Sorry. But this should be roughly the way that you interact with Apex Tail in DX. We say, hey, we're going to log a tail, we're going to run our test, and then we're going to review that log. All right within the command line, which hopefully you're all getting used to. This should be going GA in winter, if I am correct in that. So it is just a beta right now. So any feedback that you have, send it to the DX team so that we can continue to work on this feature for you. The next tool that I really want to point out and that I am so excited about as somebody who doesn't live in the CLI all day is Apex Replay Debugger. This is a VS Code extension that you can go install right now into your org. And it allows you to set breakpoints, which is something we've never been able to do before in Apex, as well as whitelist users and request types. So, like I said, you can get started with it today, go to your VS Code, look for Apex Debugger or Apex Replay Debugger, and install it. You don't have to install it globally, you can just install it for you. So this isn't something that should inhibit you from being successful. Okay, so the next step for all of you in the room, after you ask me all of your lovely questions and you go to the keynote in about 20 minutes where we're going to show you how to use those 2 previous tools, is to get started on Trailhead. Trailhead is the fun way to learn Salesforce. It's probably why a lot of you are here at Trailhead DX. But there's a lot of different modules on there, and particularly one that I love called Apex Testing. Now, it doesn't talk about all this advanced features. We're working on those badges now, but it does talk about the basics and really helps you actually practice it in an org that's maybe not your production org. So thank you for attending today. I've got about 5-ish minutes to answer some questions, and I'd love to hear what you have to say. There are 2 mics if you want to go up to the mic to ask your question.
Hello. Hi.
Hi.
I have a question. Is there any roadmap for creating out-of-the-box testing thing for Lightning components, not using Jasmine and all those things?
So I don't know what our roadmap looks like. I do know that we're working on it. If you go to lightningroadmap.com, you'll be able to see really in depth what our roadmap looks like, but it doesn't have a whole lot on it related to testing. So it is something that I've been working with them to ask about because it's something that should exist for us.
Thank you.
You're welcome.
Hi. When you said there's a system.assert statements, if
Yes.
they're not there, it's not a test. Then why are they not required?
Why
Is
are they
there
not
a
required in a test?
Is there a scenario where you don't need to use that in the test class?
I cannot think of a single scenario where you don't need to use them, but it's also really hard for us to require them in your test suites. So,
Okay. So any plans on changing some of those things or no?
I don't think so, but
Okay.
you should definitely write them in.
Okay. All right, thank you.
Thanks.
Hi, hopefully you'll be able to answer this question. With deployments that have process builders,
Yeah.
when you have unit tests that we write usually, that will, if there's a change in that process builder that affects tests and deployments, those aren't activated. So that, again, we have to essentially do 2 deployments to essentially comment out the new functionality, deploy the code, and then do another one with the
process builder.
Is there any, do you know, is there any change so that you can actually have the process builder activated when you're running the unit tests so that it's not a 2-step process?
Man, that would be nice. I don't know. Let me ask
No,
and
appreciate
see,
it.
because that is a really good use case. Yeah, I don't know.
All right, thank you.
You're welcome.
Hi. I have some legacy code in my org that now when I run it, or the test code, that now gets mixed to DML errors.
Okay.
I was wondering if the test factory that you mentioned earlier, if that would help with that at all.
That should help with mixed DML errors because you're going to standardize how you're getting your data.
Okay.
But the other thing is that I would update your APIs. So I don't know how regularly anyone does that,
Okay.
but it is something that I try to do when we release new code, is that I also update my API to that new API number.
Got it.
And that prevents errors like not seeing all test data and mixed DML things.
Okay.
Because then you'll catch it early on.
Okay, great, thank you.
You're welcome.
You said there was a beta for the Tails feature. How does one get on that beta?
It should already be enabled. It's just beta. It's not fully fleshed out yet.
Okay, cool. Thank you.
Any way to unit test private functions? Because I've taken private functions and made them public just to write unit tests for them. Add test visible? Okay, all right.
What did you say? Add test? Add test visible. Yeah, I knew that. Add test visible
Okay.
above your method.
Slightly peripheral, but when the hammer runs and it runs all your unit tests for the updates,
Yeah.
what happens when tests fail?
So the first thing that happens is we look at the fact that it's failed, and we evaluate whether or not we think it's our failure or your failure. And typically, we will reach out to the org if it is something that we think could be both of us to figure that out. But honestly, most tests don't fail. It's just a backup that we do to make sure. But if there is something that we see, we always reach out to the org first and say, hey, we're seeing this problem. Let's chat and see if it's our bug or yours.
Cool, thanks.
I have some legacy code. So I have a trigger that calls a class, and I have a lot of methods in that class. So now when I'm writing a test class, that's basically for the trigger. So what happens is when I check the code coverage, it shows me 100%. But, I go and make changes in the class that is being called. So how do I ensure that whatever changes are being done in the called methods, those are really, I'm covering all that.
All of that. So our code coverage mechanism is not going to tell you that.
Yeah.
Really, that's going to be up to you and writing out which paths should be, right? Like, it's just a documentation exercise to make sure that the things that you're testing are the things that are actually needed to be tested.
Right. So I don't have any mechanism of testing whether I'm
So, I mean, I would just say, like, you should go back to your code and really read through it and figure out what those paths are going to be. But that's really a developer exercise, and there's nothing that I could do to help you with it.
Okay. Thank you.
You're welcome.
Hey, just wondering how I'll get the slides, a copy of the slides from today's.
Yeah, so the slides should be posted. If they're not posted, then I will post a link to them in the YouTube video when that gets posted. But all slides should get posted to the Trailhead DX site.
Okay.
I just haven't seen them up there yet.
All right.
Otherwise, it'll be on the YouTube recording, which will be out in about 2 weeks.
All right, cool. Thank you.
Can you talk just a little bit about what tools you guys are using for regression and how you decide how much regression to do?
That's a good question. So I don't know what Salesforce uses for regression testing.
Okay.
Should maybe ask. But personally, I don't really have an answer.
That's okay. I just thought I'd ask.
Yeah, no.
Beyond
I mean, regression testing is definitely something that's important. Typically, what I would do is I just run my whole suite of tests and see, like, how we're doing. But I don't have, like, a specific path that I go down or a tool that I use.
Off of, like, the test or the code coverage.
Right.
Okay.
I know, like, Jenkins has different things that you can do to automate some of that regression testing. I just haven't messed with it too much to be able to give you a good answer.
No problem. Thanks.
Hey, I'm sorry.
It's okay.
Is TDD a good practice with Salesforce? The test-driven development?
I'm sorry, I can't hear you. Can you speak into the mic a little bit more?
Is TDD a good practice with Salesforce?
So I'm a huge fan of test-driven development. It's actually the only way that I write my own code. So it works fine with Salesforce. It's just that it's not everybody's preference. So I would recommend that if you are interested in becoming a better better person that writes tests, that you try out test-driven development for a while, because it kind of changes the way that you think about how you're writing your code. But it's not necessary by any means. But it does work really well in Salesforce.
Okay, thank you.
At least for Apex. Not so much on the JavaScript side yet. Well, thank you for the rest of you that have hung out.